So good morning everyone. From today we are going to start the compression member, design of the compression member. So everyone can see my screen. Is my screen visible to everyone?
Yes, ma'am.
So now as you can see here the compression member, in compression member you need to design the struts and the columns. Strut is nothing but one of the member of the roof truss. We are seeing what do you mean by the roof truss. So the roof truss is basically a truss or shed, that is a steel shed that is being used in the commercial towers mostly. Or roof truss is also being used in the railway stations, as you have seen in the Mumbai. In most of the railway stations, for making a shed, the roof truss is being used. So strut is nothing but one of the member of the roof truss. So that we need to design. So for that, as you can see, this is which type of truss is this? Yes, anyone from you? Sorry. Which type of truss is this? There are many different types of the truss, like hot truss, pink roof truss, steel roof truss. This is a type of the pink roof truss. Queen post, yes, queen post and king post. There are also these two types also, king post and queen post truss. But this particular, this is a pink roof truss. So you need to calculate the slenderness ratio also. Now, what do you mean by the slenderness ratio? The formula to calculate the slenderness ratio is lambda. Lambda will be equals to KL upon R minimum. So lambda की value should always be less than 180. That is the slenderness ratio should always be less than 180. And the value of R is nothing but the radius. So the value of R is to be calculated by using the formula, that is R equals to under root of I by A. यहाँ पे अभी I क्या है? Yes, what is I over here? What is I? Yes, you can unmute yourself and you can speak. What is I over here indicates?
Moment of
Yes, moment of inertia. I is nothing but the moment of inertia, absolutely correct. And A is your area. So the formula to calculate R is under root of I by E. Now what is mean by exactly slenderness ratio? Slenderness ratio is nothing but the tendency of the member to buckle. The tendency of the member to buckle is usually measured by slenderness ratio. जब भी आपका कोई member अगर buckle हो रहा है तो उसकी buckle होने की जो tendency है, that is nothing but the slenderness ratio. And the formula to calculate the slenderness ratio is KL upon R minimum. So just note down the formulas for slenderness ratio and definition for slenderness ratio. And after completing this, let me know. And if any doubts in this, you can ask. Yes, all of you had completed the formula for slenderness ratio. Everybody had written this formula. Yeah, completed. Should we proceed further? Okay. So after this, we are having the permissible limit of lambda. So there are some limits, मतलब जिससे कि आगे आपकी slenderness ratio की वैल्यू नहीं जा सकती है. This is on the table number 3, page number 20 of your IS 800 2007. Wait, I will show you. See, as you can see, here there are the maximum values for slenderness ratio. As you can see over here, ये जो particular table है, that is your table number 3 on the page number 80. There are the given values as per IRC, that is a maximum effective slenderness ratio, that is KL by R minimum. मतलब this is your maximum value, इसके आगे आपकी value है वो नहीं जाना चाहिए. So as you can see over here, a member carrying a compressive load resulting from the dead load and the imposed load. If the members is having both dead load and imposed load, मतलब अगर मेंबर में दोनों भी है, डेड लोड भी है और लाइव लोड भी है, तो आपकी जो मैक्सिमम स्लेंडरनेस रेशियो की वैल्यू है, दैट इज मैक्सिमम वैल्यू फॉर द लैम्डा is 180. And suppose if the tension member in which the reversal of direct stress occurs due to the loads, मतलब अगर डायरेक्ट स्ट्रेस ऑकर हो रहा है ड्यू टू द डिफरेंट लोड्स, मतलब कौन से डिफरेंट लोड्स उस पे एक्ट हो रहे हैं, लाइक wind load, seismic load, if the different loads are acting over there and if the reversal of direct stresses is being occurring, मतलब जो आपका डायरेक्ट स्ट्रेस है वो भी occur हो रहा है, तो again your value should be maximum 180. Like this, as you can see over here, depending upon your different members, there are the different values for slenderness ratio. So you have to take these values from this table, that is from the table number 3, your page number 20 of your I score. Now effective length of the member. अभी effective length कैसे consider करोगे? See, this member, this is of the, again this one is your angle section and this one is your gusset plate. So it is of the type continuous member. So इसमें KL की वैल्यू रहेगी 0.7L to 1L. अभी ये कहाँ से आई? और अगर discontinuous है, मतलब अगर continuous और discontinuous, I think everyone understood. कंटिन्यूअस किसे बोलते हैं और डिसकंटिन्यूअस किसे बोलते हैं. कंटिन्यूअस मतलब अगर उसमें कुछ भी ब्रेक्स नहीं है, कुछ भी बोल्ट्स, कुछ भी बीच में ब्रेक नहीं हो रहा है वो बीच बीच में, सो इट विल बी योर कंटिन्यूअस स्ट्रट. एंड इफ इट इज ब्रेकिंग यू हैव टू जॉइंट इट विथ सम अनदर मीन्स, that is your discontinuous one. So for continuous, again the value for the KL will be 0.7L to 1L. Again that value, from where you will consider that value, you will consider that value from the page number 35 of your IS 800 2007 from the clause number 7.2.4. Refer your IS codes. And if it is discontinuous, what will happen? The value for the KL will be 1L. Then again, if this type of member is there and if you want to calculate the compressive strength of this kind of member, अगर ऐसा member रहा, so it is of the discontinuous, अगर रहा तो उसकी L की value रहेगी 0.7L to 0.85L. L is nothing but what? L effective. Again that value you are going to take from the page number 48, 7.5.2.1. I will show you in the IS code, page number 48. See here. Here it is mentioned for different values of L. The effective length KL in the plane of the end gets thrust is 0.7 and 0.85 times. So depending upon that, you have to consider all the effective values. And again, as you can see over here, यहाँ पे आपको different values दिए for the constants. अभी in next formula, we are going to calculate the values for the constant, that is K1, K2 and K3. So from this table, you have to take that values of all the constant, that is K1, K2 and K3. Again, for if it is a continuous one, the value for the KL will be 0.7L to 1L, और अगर discontinuous रहा तो 0.7L to 0.85L. Same अगर ऐसे type का trust रहा तो values will differ. Again from the page number 48. You can note down these all the values for continuous and discontinuous one. And if any queries, you can ask. Yes, I will scroll up. Yes, completed. Should I scroll it down?
Yes, ma'am. Scroll down a little bit.
Okay. Yes, completed. Everyone had understood up till here. Any queries? If you are having any of the doubts, you can ask. Is completed or not?
Yes, ma'am, completed.
Okay. What about others? All the others are also done. Should I proceed further?
Yes, ma'am.
Yeah. Now, for single angle strut member, if you want to calculate the strength of the single angle, that will be loaded in the compression. अगर single angle strut के लिए आपको compressive strength calculate करना है through one leg, so that will be calculated from the formula, that is lambda I. If you have to calculate the compressive strength for the single angle that will be loaded with the one leg, you are having the formula, that is lambda I will be equals to the under root of k1 plus k2 into lambda vv square plus k3 into lambda into phi square. Again, this formula is on the clause number 7.5.1.2 of your IS 800 2007. So as you had seen just now, there are the different formulas, there are the different values for K1, K2 and K3. And K1, K2 and K3, K1, K2 and K3 is nothing but the constants. But from that table, you have to take the values of K1, K2, K3. That is on the page number 48 of your IS 800 2007. I will show you that table in your IS code where it is exactly. See, this is your clause number 7.5.1.2. यहाँ पे formula is given to you for the lambda I, that is k1 plus k2 into tau vv square plus k3 into lambda into phi square. So again, lambda vv और lambda phi के लिए you are having the formula, that is L upon R vv epsilon into under root of pi square epsilon upon 250. Or lambda phi is given by the formula b1 plus b2 by 2t upon epsilon into under root of pi square epsilon upon 250. Where here L is nothing but the center to center length of the supporting member. Center to center length between the supportive member. The clause number 7.5.1.2 is for the calculation of the lambda, calculation of slenderness ratio for the this this one single angle strut member. सिंगल एंगल स्टड मेंबर के लिए अगर आपको लैम्डा की वैल्यू कैलकुलेट करना है तो यू आर हैविंग दिस क्लॉज नंबर, दैट इज 7.5.1.2. एंड अगेन P is nothing but the thickness of the leg, epsilon is your real stress, और B1 और B2 क्या है, width of two legs of the angle. As you know that there are the two legs of the angle, कोई भी एंगल को दो लेग रहते हैं, so B1 and B2 is nothing but the width of that legs. Then K1, K2, K3. अभी K1, K2, K3 क्या है? K1, K2, K3 is nothing but the constants. So अगर आपकी गसेट प्लेट का कनेक्टिंग मेंबर अगर फिक्स्ड है, if it is fixed, then you are having particular values for the constant K1, K2, K3. Means you are having the values 0.2, 0.35 and 20 if the member is fixed. And if the member is hinged, you are having the different values, that is 0.7, 0.6 and 5. And here the number of bolts at each end connection is given to you. So if the number of bolts is greater than 2, this condition you need to follow. And if the number of bolts is 1, you need to follow this condition. So no need to learn the formulas. Just remember the clause numbers. From that clause number, you can refer the formulas from your IS code. So just note down the formula for calculating the single angle strut member that is being given in the clause number 7.5.1.2. And if any of the doubts, then you can ask. Yes, Abdullah, hope you understood. Okay. After completing, let me know. uh, by tomorrow, in tomorrow's lecture, I will show you. Okay, everyone had completed up till here. Everyone had noted this formula. Okay. Yes, all the others had also done. Should we proceed further? Okay. Now, as you had seen in the IS code, the on the same clause number, that is 7.5.1.2, there are again two formulas to calculate lambda VV and lambda phi. So the formula to calculate lambda VV is L upon R VV epsilon. This particular term is known as the epsilon under root of pi square epsilon upon 250. Then same for the lambda phi, we are having the formula that is V1 plus V2 upon 2t upon and epsilon into under root of pi square e by 250. वहाँ पे L क्या है? L is nothing but center to center length between the end connections, and RVV is nothing but the radius of gyration about the minor axis. So just note down this formula for lambda VV and lambda phi. Here the angle section is being shown to you. On the same page number, you are having these formulas in your IS 800 2007. No need to learn these formulas. One is E and one is epsilon. Wait, I will tell you. अंडर रूट में जो है ना पाई स्क्वायर ई है वो, और बाहर जो है डेट इज नथिंग बट द एप्सिलॉन. जो स्क्वायर रूट के अंदर है डेट इज योर पाई स्क्वायर ई. द ई इज नथिंग बट द मॉडुलस ऑफ इलास्टिसिटी. मॉडुलस ऑफ इलास्टिसिटी की वैल्यू यू हैव टू कंसीडर डेट इज 2 into 10 to power 5. जो अंडर रूट के अंदर है डेट इज पाई स्क्वायर ई, और जो बाहर है डेट इज नथिंग बट द एप्सिलॉन. Okay, everyone had done up till here. Yes, IS codes में both are epsilon, but one is E. There is slightly printing mistake in the IS code. But जो स्क्वायर रूट के अंदर है ना वो E है, और स्क्वायर रूट के जो बाहर है डेट इज एप्सिलॉन. IS कोड में देखने जाओगे तो आपको दोनों भी एप्सिलॉन जैसे ही दिखेगा. Okay, everyone had done up till here. Should we proceed further? Yes, completed or not? Yes, Roshan, Ibrahim, Josh, had you done up till here? Okay. What
Yes,
about
ma'am.
others? Yeah. Okay. Now here B1 is nothing but the width of two legs of the angle as I've showed you in the IS code. T is nothing but the thickness of angle. Fy is nothing but the yield stress. Mostly yield stress we are going to consider it as 250 only. So epsilon is under root of 250 by Fy. So Fy as we are going to consider it as 250. So mostly the value for the epsilon will be 1 over here. Then is nothing but your Young's modulus, that is modulus of elasticity. For that you have to consider the value that is 2 into 10 raised to power 5 megapascal. So do up till here, then we shall proceed further. Okay, done. Everyone had completed up till here. Okay. Okay. Now the design compressive strength PD is a member that would satisfy the following conditions. That is, P should be less than PD, and the formula to calculate PD is A into FCD. So A is nothing but the effective sectional area, and FCD is nothing but the design compressive strength. Again, it is given on the clause number 7.1.2. So यहाँ पे these conditions should satisfy to calculate the design compressive strength. The design compressive strength is denoted by PD, and P should be always less than the design compressive strength, that is P suffix D. And the formula to calculate PD is A into FCD. AG is your gross sectional area and can be considered as a effective sectional area. अगर आपका section अगर semi compact है, so you can consider the value of AG as AE. मतलब जो आपका gross sectional area है, जो आप steel table से value लोगे, that is nothing but the effective sectional area also you can consider over there. If only and only if your section is semi compact. When we will solve the problems, your ideas will be more clear. So just note down the formula to calculate the compressive strength. But before that, we are having less less than a minute. Last 1 minute is there. So those who are not given the attendance, give your attendance in the chat box and rejoin the lecture again after 10 minutes. Everyone note down these formulas to calculate the design compressive strength PD and rejoin the lecture again after 10 minutes. Okay. And if any doubts, you can ask. Yes, everyone had noted up till here. Okay.